All right, today we're going to be talking about operations with polynomials. Now I'm going to split this section into two. So today we're just going to be dealing with the monomial types, then we'll deal with polynomials tomorrow. So when I'm dealing with monomials, we're going to multiply and divide them and simplify the monomials as best we can. Now we have several different powers. It goes on to 2 pages here. I blew it up. They put it onto 1 page and it was really, really small. So I put 2 here for you. So let me go over this one. We have the product and the quotient of powers. Now, when we're dealing with the product, in other words, when we're multiplying, we end up taking these two exponents, a plus b, and we add them together. So 2 and 4 become 6. Notice we don't change the base. It's base 3 here, and it stays base 3 or 3 to the 6th. And the same with the variable. Obviously, the variable is real easy to do. But notice I do not change the base here for the numbers either. Quotient. The quotient again is division. So when we divide, we added when we multiplied. So when we divide, we are going to subtract. So 5 minus 2 was 3. 6 minus 4 is 2. And so that's what we're going to have to do. So when we multiply, we're going to add them together. When we divide in a fraction form, we're going to subtract them. All right, what other things can we do? Negative exponents. Negative exponents always go down to the denominator. So x to the negative a becomes 1 over x to the a. If there's a fraction, it goes down with the denominator there, and so on and so forth. It is possible for 1 to be in the denominator and move it up to the numerator. The negative does just kind of mean that it switches, but for the most part, we're going to take a negative exponent and move it to the denominator, like 3 to the negative 5th becomes 1 over 3 to the 5th. Notice when we move it, we do get rid of that negative. The negative means it's in the wrong spot, so we want to make it positive. Power of a power, we just distribute because we end up writing this out that many times. If I have x to the third squared, I have 2x to the thirds. So it's 3 plus 3 or 6. If I have d squared to the fourth, I have 4 of them. So 2 plus 2 plus 2 plus 2 plus 2, or d to the 8th. Same kind of thing, we can go backwards. If it's on the outside, we can put it on the insides here. And then anything to the 0 power is just 1, or we usually don't even have to write it. So 7 to the 0 power does equal 1. So if they cancel out, then we don't need to even write it on there. That's what that's for. So let's go ahead and do some examples. Oh, I'm sorry. One more key concept. We need to simplify our monomials. So what does that mean? It means that there's no powers to a power. So we can't have x squared to the third. We have to simplify that. Each base only appears once. We can only have 1x, 1y, 1z. All fractions have to be in simplest form, so we reduce our fractions just like normal. And we can't have any negative exponents. So we'll go through how to do all of those as we go through. But those are 4 things you have to make sure that you keep as your part of your answer. None of those can happen. All right. So here's our first problem. A to the negative third, a squared, b to the fourth, c to the negative first. Now notice these are multiplications. Since they're multiplications, we are going to add exponents. But we're going to only add exponents of bases that are the same. Notice we have 2 different a's. So I'm going to add those exponents. So here's the 2 different a's. We have negative 3 and 2. So negative 3 plus 2 is negative 1. So that's one of our exponents that we're going to get. Notice that I didn't do anything with the b or the c because there is no other ones with them. I can't add anything if there's not a thing there. So I have a to the negative 1, b to the 4th, c to the negative 1. Now this is simplified, but notice we still have negative exponents. We can't have negative exponents. They have to be changed. Remember, negative exponents go down to the denominator. So it's b to the 4th over a to the 1st, c to the 1st. Again, you don't have to put the first there if you want. And so that's my answer. Let's try another one. Now here we have a couple that we can put together. We have x to the negative 2 and x to the negative 3. So I put those together and I get negative 5. Y to the negative third and y to the 5th, that's 2. And z squared doesn't have any 1, so we're not even doing that part. So now I'm going to rewrite it. X to the negative 5th, y to the 2nd, z to the 2nd. Again, last step is making sure that negative exponent goes down to the denominator. And that's simplified. Well, what happens if it's in a fraction form? Remember there, we go ahead and we subtract. So we're going to do 2 minus 10. Well, 2 minus 10 is negative 8, and negative 8 becomes goes to the denominator. If there's nothing left in the numerator, we can just put a 1 there just to keep track of it, just like we could put it over 1 if we wanted to, anytime over here. But this is our answer, 1 over n to the 8th. So what about these squared parts here? Well, squared parts, remember, we can just go ahead and distribute. So that becomes 3 squared, a cubed squared, and b to the 4th squared. That's what all of these happen. They just kind of distribute. This can be distributed to each of the parts in the middle. And so then I can go ahead and do this. 3 squared is 9. 3 and 2, multiply that, that's 6. And this is 8. So a to the 6th, b to the 8th. And we have 9, a to the 6th over b to the 8th. All right, what about this one? 4x squared y to the 5th, 2x cubed cubed. So one way that we can go ahead and do this is, what does cube mean again? It means multiplying itself 3 times. So we have 2x cubed, and 2x cubed. So this one has no power here, so it's just there once. Well, all the numbers in front get multiplied together. 4 times 2 times 2 times 2 is 32. And then the variables we have x squared, x cubed, x cubed, x cubed. So 2 plus 3 plus 3 plus 3 is 11. We only have that one y, so we don't have anything to do with it. Now putting it together, 32x to the 11th, y to the 5th. No negatives, no fractions. We're good. That's as far as we need to go. What about this one? 15 over 25, x to the 3rd, y to the 2nd, over 25, x squared, y to the 8th, and z to the negative 4th. So we have a fraction here, so we're going to reduce it. 15 over 25 becomes 3 over 5. The x's we have, and because this is a fraction, a quotient, we're going to divide it. So 3 minus 2, which is 1. The y's get negative 2 minus 8, which is negative 10. And notice what happens with the z. There's no z's on top, so that's why I put a 0 here. So I have 0 minus a negative 4. Well, 0 minus a negative 4 is positive 4. So I'm going to rewrite this. I have my 3/5 here, x to the 1st, y to the negative 10th, and z to the 4th. Now I need to go ahead and write this correctly. This y to the negative 10th is going to go down to the denominator. I already have a 5 in the denominator, so those two are going to go together. The 3 is in the numerator, and these other things are going to go with it. So 3x, again, I don't have to go x to the 1st, z to the 4th, over the 5, y to the 10th. That's what I have for you today.